This will be lesson 2-3, slope-intercept form. Our learning target is slope-intercept form. Our unit on linear functions and models falls under big idea number 2, functions, equations, and graphs. In our process skills, we will graph and write. Our guiding questions: what is slope? Slope is the ratio of vertical change to horizontal change. Which can be simplified to rise over run. And guiding question number 2, what do the graphs of linear equations look like? They are lines. Our enduring skills, math practice standard number 1, make sense of problems and persevere in solving them. How? With the knowledge of direct variation, which we did in lesson 2-2, you will construct and graph linear equations and explain correspondences between graphs and equations. The slope of a non-vertical line is the ratio of the vertical change to the horizontal change between 2 points. If we look here, we can calculate the slope by finding the ratio of the difference in the y-coordinates to the difference of the x-coordinates for any 2 points on the line. If we look in our key concept box here, it says the slope is the ratio of vertical change to the corresponding horizontal change. We have y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1, where x sub 2 minus x sub 1 can't equal 0 because we can't have 0 in the denominator. Does it matter which point you use for x sub 1, y sub 1, and x sub 2, y sub 2 when you find the slope? No, it doesn't matter. And we will see this in the coming problems. So now, problem 1, finding slope. What is the slope of the line that passes through the given points? Remember, it's the ratio of the vertical change to the horizontal change. So that means my slope, which is m, I can figure out by taking the y value of the first point, 7, and subtracting the y value of the second point, 4. That's my vertical change. And I put it over my horizontal change. My x value of my first point, -3, minus my x value in my second point, -2. And then I just calculate. So I have 7 minus 4, which is 3. -3 minus -2, which would be -3 plus 2, which would be -1. Then divide, and I get my slope is -3. And we can tell here, I can go ahead, I can do it the opposite way. I can take the y of my second point and subtract my y of my first point and put it over the x of my second point minus the x of my first point, which would give me 4 minus 7 is -3, -2 minus -3, which would be +1, which when you divide, you get -3. Same thing. So it doesn't matter which point you start with, as long as whichever point you start with for your y's on the top, you start with its corresponding x on the bottom. So now let's do a couple more. For b, I've got my y, 1 minus 1, over my x, 3 minus negative 4. 1 minus 1 is 0. 3 minus negative 4 is 7. 0 divided by 7 is 0. And if I have a slope of 0 indicates a horizontal line. Indicates a horizontal line. Which means that all my y values will be the same. Now if I look at example C, I have my slope m. It's going to equal negative 3 minus 1 over 7 minus 7, which will give me negative 4 over 0. And remember, in algebra we can't divide by 0, so that means my slope is undefined. When I have an undefined slope, that means that I have a vertical line. And when I have a vertical line, all of my x values are the same. Okay, looking here in our concept summary box, it shows the 4 possibilities for slope. When my line rises from left to right, I have a positive slope. When my line falls from left to right, I have a negative slope. When I have a horizontal line, I have a 0 slope, like we talked about in the above examples. And when I have a vertical line, my slope is undefined. A function whose graph is a line is what we call a linear function. You represent a linear function with a linear equation such as y equals 6x minus 4. That means you have a first degree x, which means that you're not going to have like x squared, x cubed, x to the 4th power. You're just going to have an x. It means x to the first degree, which we just write as x. And a solution of a linear equation is any ordered pair that makes the equation true. So if I substitute the xy of an ordered pair into its linear equation, it should be true. Now, a special form of a linear equation is called slope-intercept form, and we did talk about this in Algebra 1. An intercept of a line is a point where a line crosses an axis. The y-intercept is where the line crosses the y-axis. And it will have the coordinates of 0 and then whatever y value that you have there, because we don't go anywhere left or right, we just move up and down. And then our x-intercept is where the line crosses the x-axis, and its point will always be wherever that x is, and then its y will be 0 because you don't go anywhere up or down, you just go left or right. Our slope-intercept form of an equation is the formula y equals mx plus b, where m is the slope and 0b is the y-intercept. If we look at problem 2 here, writing linear equations, if we look at example A, it asks us what that equation would be. Knowing that my formula is y equals mx plus b, I know here that my m is 1/5, sorry. So in place of my m here in the equation, I can put 1/5. And I know that my b is -3, so I'm going to put -3. So the equation for a line with a slope of 1/5 and a y-intercept of 0, -3 would be y equals 1/5 x minus 3. If I look at example B, in order to write the equation of my line, I need to know my y-intercept and my slope. If I look here on this graph, I have a y-intercept of 4, because that is where it's crossing the y-axis. And then if I look here, I have my y-intercept point and I have another point on my line right here. If I calculate my slope by doing rise over run, I can tell that I'm rising 1, 2, 3, and I'm running 1 to get to that other point, and the line is falling, so I know that my slope is negative. So I'd have a slope of -3. So then I could write my equation, y equals my slope, -3x, plus my y-intercept, 4. So y equals -3x plus 4. So how do we write an equation in slope-intercept form? If I already have an equation written out, I have to solve for y. Get y by itself, and then I'll be able to have it in slope-intercept form. Because remember, slope-intercept form is y equals mx plus b. So when y is by itself, I have slope-intercept form. So if I look at example A, if I solve for y, first here, I would subtract 5x from both sides. Then I would have -4y equals, I'm going to put my x term first. So I have -5x, and the 16 is positive, so that would be plus 16. And then to finish getting the y by itself, I would divide both sides of the equation by -4. So then I would have -4 divided by -4 is y. -5x divided by -4 would be positive 5 divided by 4x, and 16 divided by -4 would be -4, so I'd have a -4. So I would have slope-intercept of y equals 5/4 x minus 4. So my slope would be 5/4, and my y-intercept, my b, would be -4. Now if I look at example B, I'm getting y by itself, so I'm going to add 3/4 x to both sides. So then I have 1/2 y equals 3/4 x minus 1. Then to finish getting that y by itself, I'm going to multiply both sides by 2, which gives me y equals 2 times 3/4 is 6/4, which simplifies to 3/2 x, and then 2 times -1 would be -2. So I'd have y equals 3/2 x minus 2. So I'd have a slope of 3/2, and my y-intercept, my b, is -2. Okay, graphing a linear equation. When you graph a linear equation, first you want to solve for y. So if I solve my equation for y, I add the 2x to both sides, and I get y equals 2x plus 1, which then gives me a slope of 2 and a y-intercept of 1. Secondly, I'm going to plot the y-intercept. In this case, it's the point 0, 1, which we plotted here on our graph, 0, 1. Then I use my slope in rise over run form. So a slope of 2, if I write it as a fraction, is going to be 2 over 1. So that means I'm going to rise 2 and run right 1. And then I could do it again. Rise 2, run right 1. And I have the points of my line. Now, the next question is, how are we going to use our graphing calculators to help us graph a linear equation? We will talk about this in class together, how we're going to use our graphing calculator. So we'll talk about this in class.